Hey guys, welcome back. Today we're going to be talking about parallel lines cut by a transversal. Our learning target for today is to identify relationships of angles created when parallel lines are cut by a transversal and apply those relationships. So our success criteria today, we have a few vocabulary words. Specifically, we have corresponding angles, alternate interior angles, alternate exterior angles, and vertical angles. We're going to figure out what exactly those terms mean and how to use them. We're also going to be able to use those angle relationships to find unknown angles. So you're going to be given figures which you don't know the angles to, and we're not actually going to use a protractor anymore. We are going to go strictly by what diagrams are telling us the angle measurements are. So the key idea here, so this is what we were talking about yesterday. A transversal is a line that intersects two or more lines at different points in a diagram. Line T in this diagram is the transversal. You should also notice that lines A and B are not necessarily parallel. That doesn't mean that line T is not a transversal. Here, it still is a transversal. Transversals literally intersect two or more lines. Sometimes they can be parallel, sometimes they don't have to be. So here is the first of the 4 vocabulary words that we are working on today. Corresponding angles. Now, what I want you guys to do is actually mark up your page just like I am marking them up with, I'm going to mark them with different amounts of arcs, okay? Because the differences in the amounts of arcs will tell us that different angles are congruent to each other. Corresponding angles lie in the same quadrant. So I always go from one intersection to the other, and corresponding angles are going to be in the same quadrant of the intersection. So notice how angle 1 is in the top left corner. So I'm going to mark that with 1 arc. Okay, just like that. Now I locate the number in the top left on the other intersection point, which is angle 5. So angle 1 and angle 5 are corresponding. I can do the same thing for all the other angles. Angle 2 is in the upper right-hand corner, but angle 2 is different than angle 1, so I'm going to mark it with 2 arcs instead of 1. And then I'm going to locate the upper right corner of the second intersection point, which is angle 6. And then, again, I can do the same thing for angle 4, but I want to mark it differently than angle 1 and angle 2. So I'm going to mark that with 3 arcs. And since that's on the lower left-hand corner, I want to look to the lower left-hand corner on the other intersection. So 8 would be corresponding to 4. Now, 3 arcs is kind of a lot. So if you get above 3 arcs, you can put 4 arcs, but I usually stop at 3, and I'll put 1 arc with maybe a little cross through it to show that it's different from the other 2 angles. So angle 3 is in the bottom right corner, and so is angle 7. So angle 3 and angle 7 correspond to each other. Okay, so that's what corresponding angles will look like. I can say I would list angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, and then angle 4 and angle 8. Those are 4 pairs of corresponding angles. Second vocabulary word, alternate interior angles. This is exactly how they sound. When they say alternate, that means that it's on opposite sides of the transversal. Okay, so when we say the word alternate, we mean on opposite sides of the transversal. Again, we're hopping from one intersection to the other. The word interior means on the inside of the parallel lines. Okay, so what I want to do is I'm really sticking to angles 3, 4, 5, and 6 here. And all I'm doing is locating an angle from one intersection. So I'm going to mark that angle 3. And then I'm going to jump on the opposite side of the transversal on the other intersection point. So that would be angle 5. Those are alternate interior angles. Same thing with angle 4 and angle 6. Those are alternate interior angles. So we mark them with the different arcs to show that they are angle pair relationships with each other. Third vocabulary word sounds very similar to the previous one. This one is alternate exterior angles. If you notice, this is the interior of the parallel lines. So that would mean the exterior is everything out here and everything out here. That would be the exterior. So when we try to imagine what alternate exterior angles would be, they're similar to alternate interior, where they are on opposite sides of the transversal, and we hop from one intersection point to the other. So angle 1 is on the exterior of these parallel lines, and if I hop on the opposite side of the transversal on the other intersection point, that would be angle 7. And then angle 2 is also on the exterior, and alternate exterior with angle 2 is angle 8, because it's on the opposite side of the transversal and it's on the exterior of the parallel lines. Last vocabulary word that I wanted to go through is actually a review from last year. In 7th grade, you did learn about vertical angles. If you forget what vertical angles are, they lie on the same intersection point and are created by two straight lines and are non-adjacent. The way that I usually go about identifying if two angles are vertical is I will locate where there's an X. Okay, I have to see an X in order to do this. Okay, and then I'm marking the angles that are across from each other. They don't actually have to be vertical, like up and down. Okay, I mean across from each other. So 4 is vertical to angle 2, and angle 1 is vertical to angle 3. You can say the same thing for the opposite intersection. If we look over here, I'm seeing an X formation, which angle 5 would be vertical to angle 7, and angle 6 would be vertical to angle 8. So those are 4 different angle relationships that are created when a transversal intersects two parallel lines. So let's actually use these names. We're just going to list all the pairs of angle relationships that we see in this diagram. So I'm just going to go through one by one and identify which are corresponding, which are alternate interior, alternate exterior, and vertical. Okay, so first off, corresponding, as we said, was in the same quadrant from one intersection point to the other. So if I start my eyes at angle 1, I'm going to mentally tell myself, okay, on that intersection point, angle 1 is in the upper left-hand corner. So I jump my eyes over to the other intersection, and the angle that is in the upper left-hand corner is angle 3. So I'm going to list angle 1 and angle 3 as being corresponding angles. I'm going to do the same thing, basically just all the way around. So angle 2 is in the upper right-hand corner, same with angle 4. So those two are corresponding to each other. Angle 2 and angle 4. See, angle 8 is in the lower left-hand corner, same with angle 6. Okay, so I'm going to list angle 8 and angle 6 as being corresponding. And then I have one last set of corresponding angles, angle 7 and angle 5. Angle 7 and angle 5 correspond to each other. Now I'm going to move on to alternate interior angles. Okay, so alternate interior angles should be only the angles that are on the inside of the parallel line. So any angle that's in there, those are the angles I'm going to denote as being alternate interior. So if I focus my eyes on angle 2, that is above the transversal. So I want to go below the transversal and be on the opposite side of the transversal and on the opposite intersection point, which is angle 6. So angle 2 and angle 6 are alternate interior. Same thing if I were to focus my eyes on angle 3. Okay, if I go on the opposite intersection point on the underside of the transversal, that would be angle 7. So angle 2 and angle 6, as well as angle 3 and angle 7 are alternate interior. If you notice, there's only 2 pairs in the alternate interior column. Moving on to alternate exterior, I'm seeing 1 is on the exterior of the parallel lines, so I want to go on the opposite intersection point on the opposite side of the transversal, which would be angle 5. Okay, so angle 1 and angle 5 are alternate exterior. And then I also have angle 8 lying on the exterior. And if I go on the opposite side of the transversal on the opposite intersection point, that would correlate with angle 4. So angle 8 and angle 4 are alternate exterior. Lastly, we got those vertical angles. Vertical angles are going to be on the same intersection point, but this time they're going to be across from each other. So if we just focus on the left intersection point and I look at angle 1 is not adjacent to, so not touching, angle 7. Okay, they're across from each other. I see that X formation. Okay, so it's kind of like I see an X with the lines that are intersecting. And then the angles that are across from each other are angle 1 and angle 7. Same with angle 2 and angle 8. Those are vertical angles. So I'm going to list those as being vertical. And just so you guys are aware, all vertical angles should be formed by 2 straight lines. I keep saying like an X formation. That's what I mean by the lines have to be straight. Okay, we can't have any bends in the line or turns or anything like that. They have to be perfectly straight, creating an X formation in order for them to be considered vertical. And then I should also be listing the vertical angles that are on the opposite intersection point. So I see another kind of X formation here, which the vertical angles, again, will be across from each other. So 3 and 5, as well as 4 and 6. So I'm going to list those. 3 and 5 are vertical. Angle 4 and 6 are vertical. Okay, and as you can see from our list of our different angle relationships, one angle could have multiple relationships with other angles. So for instance, take angle 2. Angle 2 right here is corresponding to angle 4. It's also alternate interior to angle 6, and it's also vertical to angle 8. Okay, so angle 2 is connected to many different angles for different angle pair relationships. Okay, and we're going to use that idea of connecting different angles together to find unknowns. So why don't you guys give this a try in your U-Try? I just want you to list out all the different corresponding alternate interior, alternate exterior, and vertical angles you see in this diagram. So one thing that we can use in order to find unknown angles is when the lines are parallel, okay, which is different from some of the diagrams that I was showing you in previous slides. Some of the diagrams, the lines were not parallel, and you had a transversal cutting through them. But as soon as we create 2 lines that are parallel, which I hope you're noticing, I have the little arrows that are on the lines showing that it indicates that it's parallel. Then all of those angle pair relationships that we just talked about, they're all congruent to each other. They create congruent angles. So if I say that 1 corresponds to 3, since they're corresponding, I can say that they're also congruent. So angle 1 would be congruent to angle 3. What that would mean is if I said the measure of angle 1, which when I write a lowercase m like that, that literally reads measure of angle 1. Okay? If the measure of angle 1 was equal to 30 degrees, well, then that would mean, since angle 1 is congruent to angle 3, that the measure of angle 3 would equal 30 degrees. Okay, so just knowing that angles correspond to each other, or that they're alternate interior, alternate exterior, that would mean we can make connections as to what is equal to what. And vertical angles are always congruent, no matter if the lines are parallel or not. If you see two straight lines intersecting each other, forming that X formation, then vertical angles will always be congruent. So let's actually apply this in the second example. It says find the measures of angle 1 through 3 and explain how you knew using the angle relationships. And I've indicated here in this diagram that that 100-degree angle is signifying this angle right in here. Okay, so don't get confused. I have the arrow pointing to it. And then the 80-degree angle is identifying that angle right in there. Okay, now this diagram is showing kind of in like a real life example, kind of like parking spaces. Okay, in parking spaces, all of these lines are parallel. So I'm putting the little parallel symbol on all of the lines that you see. So if I'm saying these lines are parallel, that means that corresponding angles are congruent. So if I wanted to know the measure of angle 1, well, angle 1 is corresponding to angle 80. So since they are in the same quadrant, they correspond, the lines are parallel, I can say the measure of angle 1 is equal to 80 degrees. As far as the measure of angle 2, actually, before I get to 2, I should give that reasoning, okay, because it does say to explain how I knew, explain. I can say the measure of angle 1 is equal to 80 because it is corresponding to 80 degrees. Okay, so this guy right there. I can say that the measure of angle 2 is also equal to 80 degrees because angle 1 and angle 2 are vertical of each other. So there's that reasoning right there. Because it is vertical to angle 1. And then lastly, angle 3, I can connect angle 2 to angle 3. Okay, so angle 2 is actually alternate exterior to angle 3. So angle 3 is also equal to 80 degrees. Oops, I should put my little m there for measure. Okay, and again, I'm going to put my reasoning. Because it is alternate in exterior, to angle 2. Now, did I have to use these reasonings for each of the angles? No. I could have said that, I could have said that angle 2 was alternate interior to the 80-degree angle. That's another reasoning. Okay, so if we were to look at this angle here and this angle here, those two are alternate interior. I could have also said that angle 80 corresponds to angle 3 because they're both in that upper right-hand corner. Okay, so you can actually use a couple different angle pair relationships in order to figure out what the different angles are. So let's have you give this a try in your U-Try. It says find the measures of angle 1 and 2. Give a reason why by using the angle relationships. There may be more than one correct reasoning. Also notice that the two lines are parallel. Go ahead and give it a try. couple of other key vocabulary words that we're going to use in this lesson that you may have heard before is linear pair and angle addition postulate. For a linear pair, let's break down that word. The word linear means straight line. Okay, and pair means two. So what a linear pair is two angles that form a straight line. If you notice in the diagram here, line PR is a straight line, okay? This is a straight line right there, okay? But the two angles that form PR, okay, are connected through point S, and that is angle 1 and angle 2. It's kind of like they're two pieces of pizza fitting together to form this straight line PR. Okay, so angle 1 and angle 2 would be called a linear pair. Since it forms a straight line, and we should know straight lines are 180 degrees, okay, so from R to P, that would be 180 degrees, then we would know linear pairs add to be 180 degrees. So what that means is the measure of angle 1 plus the measure of angle 2 will equal 180 degrees. Okay, so let's say, for example, I had that angle, the measure of angle 1 was equal to 20, or 120. That would mean if I subtracted 120 away from 180, I would get that angle 2 is equal to 60 degrees, because 120 plus 60 is equal to 180. Okay, so you may have different angle measures, but if they are a linear pair, they form a straight line, then they should add to be 180. The angle addition postulate is somewhat similar to being a linear pair. It basically says that if you have two smaller angles form an angle, then you can add them together to equal the larger angle. So for instance, the diagram I have here with Q, R, S, and T, I can say angle QRS, which I'm going to highlight in blue here, that angle, plus angle SRT, okay, so this other smaller angle in there, okay, add those two together, and you're going to get the larger angle on the outside, QRT. Okay, so I'm going to write that down. I've got measure of angle QRS plus the measure of angle SRT is equal to the measure of angle QRT. So the two inner angles, two smaller angles, are equal to the larger angle. So I can tell here that angle QRS is 15 degrees. And that angle SRT is 30 degrees. So I can say that angle QRS, which is 15 degrees, plus angle SRT, which is 30 degrees, equals the measure of angle QRT. So the measure of angle QRT must equal 45, because 30 plus 15 is 45. And I just have another diagram kind of illustrating the same thing. If I wanted to know the measure of, let's see, BCA, it really is the measure of angle 1 plus the measure of angle 2. Okay, so we have angle 1 here. We have angle 2 here. Put them together, you get BCA, that larger angle right there. Okay, and I can actually use this diagram in many different ways, connecting all four of the different angles together. I could even write a statement having to do with the straight line from B to D. Okay, that straight line would add together to be 180. So I can actually say in this diagram that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 forms a straight line, which is 180 degrees. Okay, so lots of different equations we can create from knowing these different properties and postulates. So let's actually use this in our third example. Alright, so in this example, it says the diagram shows part of a fence. The only angles that were shown or were measured in the diagram are shown in blue. Find the measures of angles 1 through 4 using angle relationships learned so far. So right away, I can actually just focus. If this is part of a fence, these two lines are going to be the ones that are parallel, kind of like they're the handrails of this fence. If you focus on these two lines here and one of the transversals, let's just focus on this diagonal transversal here, okay, then I can tell that this 40-degree angle is alternate interior to angle 1. So using that reasoning, since the lines are parallel, the measure of angle 1 is also 40 degrees. Because remember, all of those vocabulary words that we learned so far, those all produce congruent angles. So now I'm going to try to find 2, 3, and 4. In order to find, and I actually think it'd probably be easiest for us to focus in on now these parallel lines, so the vertical lines that are parallel. And yes, I am telling you that these lines are parallel because it is a fence, so the beams that are going up are going to be parallel. I can also tell that angle 2 and the 90-degree angle are corresponding. Okay, they're sharing the same quadrant if we're focusing in on this being the transversal. Okay, so just one of those lines being the transversal. So since 2 corresponds to 90, because they're both in the bottom left-hand corner, the measure of angle 2 is also equal to 90 degrees. And what I'm going to do is I'm actually going to label those on my diagram as well. So I'm just going to write it right on top of where those numbers are. So this was 40 degrees. Okay. And then angle 2 was 90 degrees. Okay, so now that I know those are those angle measurements, I want you guys to notice that for both angles 3 and 4, we can use that linear pair relationship. Okay, so let's look at angle 3. Okay, angle 3 is like smushed between two angles. Okay, so we have 1, 2, 3 different angles, but they're all forming together this straight line. So I can say that this 90-degree angle plus this 40-degree angle plus angle 3 should all equal 180 degrees together. Okay, so I can actually set up a little equation for that to solve for the measure of angle 3. So I have 90 degrees plus 40 degrees plus the measure of angle 3 is equal to 180. So before we solve for the measure of angle 3, I would suggest you putting the 90 and the 40 together. 90 plus 40 is 130, plus the measure of angle 3 is equal to 180. And then a little algebra review from last year in order to get the measure of angle 3. Since 130 is positive, we would subtract it from both sides of the equation. So I'm just writing what I have on the left. Minus 130 is equal to 180 minus 130. So it's like I inserted this minus 130 on both sides of the equation. So this positive 130 will cancel with this negative 130, and I'm left with that the measure of angle 3 is equal to 50 degrees. I'm going to label that on my drawing, which makes sense because if you were to type in your calculator 90 plus 50 plus 40, you should be getting 180, which is exactly what we want. And we can actually apply this same relationship to this linear pair right here. Okay, so I'm seeing that 90 plus angle 4 is going to equal 180 as well. So I'm just going to show the algebra that goes along with that. 90 plus the measure of angle 4 is equal to 180. Again, doing the same process. 90 plus the measure of angle 4 minus 90 is equal to 180 minus 90. So this positive 90 would go away with the negative 90, and I'm left with the measure of angle 4 is equal to 90 degrees. So my answers, I'm just going to circle here because it said we wanted to find the measures of angles 1 through 4. Actually, I'm going to write them all in a big list. We have the measure of angle 3 was found to be 50 degrees, and the measure of angle 4 was found to be 90 degrees. So there are our 4 answers right there. Okay, so we use those angle pair relationships to find 4 different unknown angles. Why don't you give this a try in your third U try? I'm looking for the angle measurements of 1 through 3. Alright, so now that you completed the first 3 examples, I want you to try to answer these last close and check questions. Go ahead and type your answers into the Edpuzzle, and I will grade your response based on how well you understood the material. Alright, so that just about wraps up today's lesson. We identified relationships of angles created when parallel lines were cut by a transversal, and we did this by using corresponding alternate interior, alternate exterior, and vertical angle relationships to find unknown angles. So go ahead and start your practice. Please make sure you ask any questions you made or rewatch any of the sections of this lesson to make sure you understand what's going on. Alright, have a great day.